Hello everyone, this is Mr. B with Algebra 2 Notes 1.6, Inequalities. This is the last chapter, or the last section of Chapter 1. Really, it's just all about inequalities. There are some very specific rules and kind of laws of inequalities that we have to follow, and just some simple notation that is pretty universal that we need to try to adhere to. So, when we're graphing inequalities, uh, with a less than or greater than sign, and not less than or equal to or anything like that. No equals sign, there's no bar underneath. They are drawn with an open circle. And inequalities with a uh, less than or equal to or greater than or equal to sign are drawn with a closed circle. So if we were to graph out this inequality here, um, -3 is less than x is less than 4, we would definitely label our graph. You don't need to put 0 in. It's not always necessary. But if it's a less than and not a less than or equal sign, we would do an open circle and an open circle, and then we'd clearly mark the center of that line, just the direction in which it goes. For this next one, again, make sure you mark and label your inequalities. And this is a equals sign, so it would be a closed circle. Same thing with this 1 over here, and then we'd fill in the rest. Great, pretty straightforward there. Compound and simple inequalities. So compound inequalities will have two inequality symbols. When working with an and compound inequality, uh, both inequalities are true, and when working with an or compound inequality, either are true. That will make more sense as we go through, but just know that when we're working with and, both of them must be true, kind of the intersection of them, and when we're working with or, either of them can work. A simple inequality will have only one inequality symbol. These inequalities will typically go off to infinity in either direction. So let's look at some properties of inequalities. When performing operations around an inequality symbol, you can do anything that you would normally do to an equation with an equal sign. There is one additional step for some of those operations, though. When you multiply or divide by a negative, the sign must change direction. And just to kind of um, show that as a straightforward example, we'll work on these two identical problems, but we'll kind of simplify them in different ways. So to simplify this equation with addition, you would just add x to each side. And that would give you 0 is less than or equal to x. And if we were to simplify this equation with multiplication or division, really your choice, if you multiply by -1 and multiply by -1, you would get x, and the sign would flip. It's less than or equal to 0. And when you're looking at both of these equations, even though they're on separate sides of this inequality, they're really the same. If we draw this out, there's 0 right there. If 0 is greater than x, we would want to go this direction. That's off to infinity. And then for this one, what am I doing? Mark that as 0 with a closed circle here. If x is less than 0, we would go this way as well. So a good example as to why we would flip that sign. It really is affecting that sign as well. Now, with the last section of notes, we were looking primarily at absolute value signs, and inequalities with an absolute value sign look kind of unique. So if the absolute value is less than some number, then it is the negative of that number is less than x is less than the positive of that number. And you'll see what I mean as we go through. And if the absolute value is greater than some number, we'll just say n, then it is an or inequality. And you're going to have it shoot off in two different directions. And we'll kind of see that here. So first off, I'm just going to mark these as 0, -4, and 4, and 0, -4, and 4. So what are these really asking? We're asking for any value when we take its absolute value is greater than 4. So if you want to think of it in these terms, we would draw an open circle on either of these. And if we pick something that's super, super negative, we go to negative, I'm just going to pick a number, 256.3, and we take the absolute value of that, it would just be 256.3. And that's definitely greater than 4. Same thing if we take an incredibly positive number, say positive 3,188.73, just to pick a random number. If we take the absolute value of that, it's going to be exactly the same, which is definitely greater than 4. So that's why we're going to be looking at kind of an open space in the middle, and then it shoot off to positive infinity and shoot off to negative infinity. The next one here is if we're looking at it kind of reversed. We're looking at all values that when we take the absolute value of it, they're less than 4. And this is going to be bound. There's not going to be an infinite number of numbers that we can select. It's going to be limited to everything between 4 and a negative 4. That's what we're looking at there. If we pick something that's incredibly positive, say this number again, 3,188.73, and we take the absolute value of it, that's way bigger than 4. Even if this is negative 3,188.73, it's, once we take the absolute value of it, just going to turn positive, and we're going to be left with something that's far larger than 4. And that's why we're looking at something where we're just looking at the center of it and not everything towards negative and positive infinity. Let's jump through some examples. They'll make more sense once we actually get the pens in our hands. So this first one, I can add 6 to all sides of the inequality. We'd want to add it to all 3 sections. So negative 3 plus 6 is 3, is less than 3x, is less than or equal to 6. And then we can divide everything by 3. And we can get x, what am I doing? 3 over 3 is 1. 1 is less than x is less than or equal to 2. And to graph this, we want to put those 2 sections in. We'll look at 1 here and 2 here. And we'll fill in everything. Now on the 1 side, if we're looking at this section of the equation, it is a less than. It's not less than or equal to, so we'd draw an open circle. And for this side of the equation, we're looking at a less than or equal to sign. So we would fill in that dot. Fill that in dark. And that's exactly what we're looking for. For this next one here, let's see. We will have a negative 2, so we'll take 2 away from every side, so we'll add 2, add 2, and add 2, so we'll have 3 is less than or equal to negative x is less than or equal to 6. Lots of 3s and 6s I've just noticed. Oh, this is over 3. There we go. Now, we can multiply all sides by 3. If we don't want to acknowledge that negative for now, we can skip over it. So we'll divide everything by 3. So 1 is less than or equal to negative x is less than or equal to 6. And now if we multiply by a negative, remember, all of our signs have to flip. So we'll have negative 1 is greater than or equal to x is greater than or equal to negative 6. And if you want to, you can flip this whole inequality around. It is a little bit easier, in my opinion, to work with them when they're pointed in this direction. So if you'd like to, you certainly can. It's not necessary, but we take this negative 6 is greater than or equal to, what am I doing? I'm not flipping the sign. There we go, is less than or equal to x is less than or equal to negative 1. Oh, and I just realized that's not a negative 6. We're looking at a negative 2. There we go. That would change into a 2 as well, because we have to divide everything by 3. And that's everything. Now we just need to graph it. We'll mark -2 and -1 here and here. They are or equal to, so they're going to be closed dots, and we'll fill in everything in between. For number 3. This one can be a little tricky. You can distribute the -3 into this binomial first, or you can divide by -3 first. It's entirely up to you. I would divide by -3 first, just because I know that that's going to be nice and simple when we divide it by a negative. So we'll divide by -3. Those will cancel out. And 0 over -3 is still just 0, but we need to remember to flip the sign. So we would have x plus 4 is greater than or equal to 0. We can subtract 4 from each side, and we would have x is greater than or equal to -4. And then we can just graph that. Right here we have -4. If we're looking for numbers that are larger than -4, we would go in this direction. Let's see. We have an x on both sides of this inequality, but that's fine. Nothing to be afraid of. We'll just take an x away from both sides. And if all the x's are moving to this side, we want all the whole numbers to come over here. So we'll add 1 to each side. So we'll have 2x is less than or equal to 16. Divide both sides by 2. 2 is not negative, so we don't need to worry about flipping the sign. X is less than or equal to 8. And then we graph it. 8 right in the middle. And if we're looking for numbers that are less than 8, we're going to go in this direction. Oh, and it's a closed circle, of course. That's everything there. 2 more, and we're all done with notes for this section as well. First thing to do, now we're dealing with absolute value symbols. So there's going to be a few extra steps. I'm going to divide both sides of this equation by 3 to get the absolute value symbol by itself. That is the very first step. So we'll have 3x plus 1 is greater than 5. But that's absolute value. So do we need to do anything really interesting with this? Not really. What I would do first, though, is recognize that we're looking for distances that are greater than 5. So we're going to have something shooting off into infinity positively, and something that's shooting off to infinity negatively as well. Because if this gets bigger and bigger and bigger, or smaller and smaller and smaller, the distance from 0 is still growing larger than 5. But we just need to know what they're going to be, and if they're open or if they're closed. So let's split this into 2 separate equations. We have positive 3x plus 1 is greater than 5. And we also have negative 3x minus 1. Remember, we're distributing a negative to every value within this absolute value is greater than 5. And now we can just simplify these. We'll subtract 1 from both sides here. We'll get 3x is greater than 6. X is greater than 2 if we divide both sides by 3. And that should work there. But which side is it going to be on? You can kind of figure this out. Well, if we're looking for x's that are larger than 2, it would definitely go over on this side. So we'll write in a 2 here, and that's an open circle. Now what about this side? Aren't we going to get something where the x's are over here, and there's some number over here, and then it will also go in this direction on the number line? Well, part of the steps of this is, let's see, we'll add 1 to both sides. I just realized I messed up on my last one here. This should be 4/3. 5 minus 1 is 4, so that's not x equals 2 at all. That's going to be 4/3, so we can write 4/3 here. All right, back to this right-hand equation. If we add 1 to each side, we'll get 6 and negative 3x, and then we'll divide by negative 3, and then the sign is going to flip. X is less than negative 2. And then we can see how these kind of work step by step. We'll find that negative 2 is going to be right here, and any values less than -2. And that's an open circle as well. One more, and wouldn't you know it, we're looking at an and inequality, less than or equal to 5. Very similar to what we did before. So we'll split this into two. We have, because this is already by itself, we have x minus 5 is less than or equal to 5. And we also have negative x plus 5 is less than or equal to 5. If we add 5 to both sides here, we'll be left with x is less than or equal to 10. And if we subtract 5 from both sides here, we'll have negative x is less than or equal to 0. We'll divide or multiply by a -1, and that will give us x is greater than or equal to 0. So we know that it's 0 and 10. So we'll mark a 10 and a 0, 0 and 10. These are closed circles. And we're looking for numbers that are greater than 0, so going in this direction, and numbers that are less than 10, less than or equal to 10. So it's going to be everything in between. Looking for this here. And if you want to jump back to the original question, we're asking for values that are going to give us a distance that is less than 5. So of course it's going to be something in the middle, just like we were looking at with our notes right here. This can be pretty complex. This can be pretty confusing. So if you guys do have questions on anything, please don't hesitate to ask us in class. We're more than happy to help out with these kinds of problems, really with any kinds of problems. We'll see you guys next time.